In this module, let's talk about how hash functions in cryptography ensures data integrity, safety and security. Cryptographic hash functions, what are they? They are special programs that ensure the integrity of data in digital applications. So the outputs of these functions are called cryptographic digests, and these are the foundational data structures upon which all the blockchains are built. A hash function takes input data of any length and returns a value that is of fixed length. This output value, called a digest or a tag, is computed in a way that is 1. The same input always results in the same output. The output reveals no information about the input, and no two inputs should result in the same output. These properties allow hash functions to make finding information more efficient, yet also difficult to reverse engineer. These functions, often considered the workhorses of modern cryptography and blockchains, are used to check for data tampering. Therefore, they are well suited to perform decentralized, permissionless building of applications. The output of a hash function, called a cryptographic digest, is a unique fixed length tag representing a single piece of data. It is used to detect tampering, since even a small change to that data input to the hash function results in a totally different output. For example, a cryptographic digest of the Harry Potter novel will differ from the cryptographic digest of the same novel with a single misspelled word. Because of this property, cryptographic digests are well suited for immutable record keeping. In a blockchain, these digests are linked together continuously to create a ledger of transactions that no one can remove, modify or tamper with. Therefore, anybody can reconstruct the blockchain from any point and verify its correctness. I know that I'm talking about a lot of terminologies and a lot of these concepts might be new. Please Google for each of these words and you will find an entire Wikipedia page that you can learn about. The next one is called cryptography private keys. So a private key is a secret number or code. A special mathematical function is then applied to this private key in order to derive a second value called a public key. So this value does not need to be kept secret because the public key reveals nothing about the private key because of the cryptographic hash function which is used. For example, a public key is the address of your house. The private key is the physical key that actually unlocks your front door. Simply knowing the address of the house does not help you to unlock the front door, right? But why does this matter? In blockchain networks, a public key is the address to which assets can be transferred to. Knowledge of the corresponding secret private key is the only way to spend those assets. Just like how you have a bank account and a PIN code. You can use a bank account to either deposit, but to withdraw, you need to use a PIN code. With public-private keys, you don't need to trust a bank. A bank is a third-party provider. You only need to trust the underlying math of a well-proven cryptographic system. The same system that already protects trillions of dollars worth of payments on the internet as on today. I have seen problems such as in Ukraine, 2 large banks got dissolved and all the money of the depositors is lost. So trusting a third party with your money does not really make much sense when you can use a much safer, secure system based on cryptography, based on cryptographic hash functions, based on private key and public key on a blockchain. In the next module, we shall talk about digital signatures, what kind of protocols exist, what are nodes, etc.